Hi everyone, welcome back. In this video, we're going to go through RE 7.1 question 1. We're going to make use of some of the things we learned in our previous videos. Try to answer these questions. Question 1 asks you to calculate the relative atomic mass. Okay, relative atomic mass of potassium and bromine respectively. I would like you, when you're doing such questions, to always write down what you're supposed to calculate. What do I mean by that? Okay, for example, calculate the relative atomic mass. This is a symbol of potassium. Then you put equals to. Okay, so how would you calculate the relative atomic mass of potassium? You first need to find out what the various relative isotopic mass of each particular potassium is. Okay, so here we have potassium 39 has a relative isotopic mass of 39. It has an isotopic abundance of 93.3. So we need to take that divided by 100 times 39. Okay, and then we will add the relative isotopic abundance, 6.73 divided by 100 times 41. Okay, this is how you calculate the relative atomic mass of potassium, and it should amount to around 39.1. Leave your answers in 1 dp. Okay, notice that there is no units because this is a ratio that we are working with. A ratio to the mass of 1/12 of a carbon atom. Same, to calculate the relative atomic mass of bromine, you write down the formula first, or rather the equation. Relative atomic mass of bromine. You always write down what you want to calculate, then you go about calculating it. So again, 50.7 divided by 100. And that is the that's the isotopic abundance of bromine 79. Then you would take that, multiply by, you take 49.3 divided by 100, multiply by 81. Okay, so this is how you get the weighted average, right? The weighted average. That's what relative atomic mass is. Weighted average of all the isotopic masses. Then you will get an answer of 80.0, right? And leave the answer to 1 dp, 80.0. Again, there's no units involved because we are dealing with relative masses. Okay, next, let's go to question 2. Question 2 wants you to calculate the MR of these compounds. MR can mean several things. MR can refer to the relative formula mass. It can also mean the relative molecular mass. When do we use which one? Right? Relative formula mass refers to the ionic compound. Relative molecular mass, we use it in the scenario of compounds or elements with covalent bonds, so rather covalent substances. Okay, but honestly, we use the same symbol for both instances, so you don't really need to differentiate the two. Just appreciate that when we see a covalent compound or substance, or we see ionic compound, when we write down MR, it actually represents different things. Okay, so let's try it out. Question 2a. Question 2a wants you to find out the relative, in this case it's molecular mass of carbon dioxide, because carbon dioxide is a covalent compound. Okay, so how would you find that out? I'm going to do a long-winded way first, just so that we slowly get into the groove of it. First and foremost, we need to know what the relative atomic mass of carbon is. We also know that there's 2 oxygen atoms per molecule of carbon dioxide. So what is the relative atomic mass of oxygen? Where do you find the relative atomic mass? You can find it in the periodic table. Okay, the bottom number. So the relative atomic mass of carbon is 12.0. 2 times of oxygen. Each oxygen has a relative atomic mass of 16.0. Together, you get 44.0. No units and to 1 decimal place. Okay, this is a ratio after all. Now let's try 2b. For 2b, we're looking at rubidium sulfite. Again, we'll write down, we want to find out instead this one is relative formula mass because it's an ionic compound of rubidium sulfite. So you need to write down the chemical formula correctly first. This is the unit formula. Okay, so how do you find out the relative formula mass of this ionic compound? You will need the relative atomic mass of rubidium, and we have 2 of that. And then you need to find the relative atomic mass of sulfur, and you need to find 3 times of the relative atomic mass of oxygen. If you were to substitute the values in after searching the periodic table, this is what you get. Okay, and the final answer is 251.1 to 1 dp. Again, no units. This is a ratio that we are dealing with. Next, let's go to question 2c. Question 2c asks you for the relative molecular mass of diphosphorus pentoxide. Diphosphorus pentoxide. That looks like this, M2O5. 2 phosphorus, 5 oxygens. Okay, 2 phosphorus. So what's the AR of phosphorus? And what is the 5 times of the AR of oxygen? You will get 31.0. That's the relative atomic mass of phosphorus. And the relative atomic mass of oxygen is 16.0. Your final answer will be 142.0 to 1 decimal place. No units involved. Let's go to 2D. For 2D, we are looking at sodium sulfate. Okay, sodium sulfate is an ionic compound. So that means this Mr that we write here is actually the relative formula mass. So of sodium sulfate. Now I'm going to skip this step. I'm no longer going to write this AR of this, AR of that. Okay. Instead, I'm just going to jump straight in and going to substitute and put in all the relative atomic masses. 23.0 is the relative atomic mass of sodium, and we have 2 of that. Of sulfur is 32.1, and we have 4 oxygens, each one is 16.0. Together we get 142.1 and 1 decimal place. Okay, getting the groove of it. Last one, 2E. They ask you to find the relative formula mass of copper sulfate. Copper sulfate is an ionic compound. But you notice this copper sulfate is a bit special. It's copper sulfate and it's also interacting with water molecules, 5 to be exact. So how do we calculate this? You would need to include the water molecules. So first off, we start off with the copper. Copper is 63.5. Sulfur, 32.1. Oxygen, there's 4 of it, so 16.0. Then let's add the water. Okay, water part is interesting. Each water molecule has 2 hydrogens, each one with a relative atomic mass of 1.0 and 1 oxygen. So it looks something like that. That's 1 water molecule, but there are 5. Okay, so this is what the formula would look like. What do you get in total? You should get in total, let's see, you should get 249.6 to 1 decimal place. Again, no units, because this is a ratio. Okay, so this is how you would calculate the relative molecular mass or formula mass. Make sure that when you do your workings, always include this statement here, just to let the marker and yourself know what you are calculating specifically. If you write out the formula wrongly, actually you cannot get the correct relative formula or molecular mass. Next, leave all your answers to 1 decimal place. And finally, check that there are no units. Okay, there are not supposed to be any units. Relative masses, we are dealing with ratios of masses. Okay, with that, we've completed question 1 and 2. I'd like you to then move on to the rest of the questions, and we will see each other again to go through.